Now, closely related to the idea of probability is the concept of odds. And if you've ever done anything with casino gambling or Vegas odds on the winner of a football game, you're probably familiar with the concept of odds. But the idea of expressing probabilities as odds is very ingrained in our culture. We do it all the time, like I said, with gambling things. In fact, an online story that was published on October the 20th of 2014 that referenced the Vegas Superbook odds board reportedly had Alabama and Ole Miss tied for the team most likely to win the 2015 college football playoff. That didn't happen, but nevertheless, with odds of 5 to 1 against. And it's pretty common to write that with a colon in between. So 5:1 is a common way to write 5-2-1. But what does that mean? In particular, what does that mean in terms of probabilities? One way of thinking about it is to think of the numbers as being associated with slips of paper. At least that's the way I think of it. When I'm looking at this 5-1 against, I'm thinking of 5 negatives or 5 nots against 1 positive, which in this case would be a win. If you think about it that way, and each of those slips of paper, think of maybe being put into a hat and drawn out, that would be equally likely. So what that tells you is that the basic probability principle applies here. So I could take these slips of paper that I've created based on the odds I was given and translate them back into probabilities. Before we actually do that, I do want to mention that when someone says that for an event the odds are 5 to 1 against, you could think of that as 1 to 5 in favor of. Typically when you look at reading Vegas odds and things like that, they're always saying them as an against. But mathematically speaking, you could say 5 to 1 against, or you could say 1 to 5 in favor. It would not matter at all mathematically. In practice, the odds written as against is more common. Before we go any further, let's make sure that everyone is on the same page with the notation, because that's important. If we say that the odds of an event are A to B against, then A is the against number. But if we say the odds are A to B in favor of, then A is the in favor number. So if it says against, the first number, the number to the left of the colon, is against. But if it says in favor of, then the first number is the in favor of number. And the B in this case would be the against number. So even though it's usually written against, if you do see it in favor of, you have to realize that that's all that's happening. You're switching the role of the in favor and against across that colon. So in the example we're dealing with now, with 5 to 1 against, the number to the left of the colon is the against part, and the number to the right of the colon is the in favor of part. But if I flipped it and said 1 to 5 in favor of, the number to the left becomes the in favor number, and the number to the right of the colon is the against number. Simple concept, but you do have to have it in mind when you see these. So back to the problem we're actually looking at. What if I wanted to turn that statement about odds into a probability? So in particular, if the odds against Alabama winning the football playoff were 5 to 1, what would the probability of Alabama winning it be? Now keep in mind, this problem came up before the result was known. Obviously, once the result is known, none of this makes any sense anymore. But going back in history and going back to this time before the result was actually known, what would the probability be of Alabama winning if we know that the odds against Alabama winning are 5 to 1? Well, that's what's so nice about thinking of these as slips of paper, because once you do that, the probability is easy to calculate, because the basic probability principle would say the probability that Alabama wins would be the number of ways Alabama could win divided by the number of elements in the sample space. Well, here's your sample space right here. The number of elements in the sample space is 1, 2, 3, 4, 5, 6. But the number of ways Alabama could win, there's only one. So by the basic probability principle, if the odds against Alabama winning were 5 to 1, then the probability that Alabama wins is 1/6. So if you know the probability of something, you can think of it as odds. And if you know the odds of something, you could think of it as a probability. They tell you the same thing, they're just slightly different ways of saying that same thing. And I hope that previous discussion helps you see how closely those two concepts are related. They're just two slightly different ways of saying the same thing. To formalize that a little bit more, I could say if the odds against an event are A to B, A colon B, then the probability of that event is B over the sum of A and B. In other words, the probability of something occurring by the basic probability principle is the number of ways it can occur. And remember, this is where you have to think. If I say odds against something, then the first number is the against number, and the second number is the for number. So when I'm doing the probability of the event, I'm looking at the probability of it occurring, so I'm looking for the for number up top. So as long as the odds are written as an against, the numerator of the probability statement will always be the number to the right of the colon. Of course, if I were saying the odds in favor of, it would reverse. But in either case, the denominator is the sum of those two numbers, A and B added together. And the key point here is no matter which way the odds statement is written, whether it's against or for, the probability is always the in favor number. So you have to find the in favor number wherever it's located in the odds statement and put it in the numerator. And the denominator is just always the sum of the two numbers, so that's sort of a little easier to do. And that leads me to another thing. Your homework might ask you, given the probability of an event, what are the odds, either against or in favor of that event? And if you look at that formula, you can see how easy answering that question really is. At least I hope you can. So if we go back to the example that we did with the Alabama winning the playoff, we calculated that the probability of Alabama winning it was 1/6. So what if I wanted to go backwards and find the odds against Alabama winning? I mean, I know what it is because that's the way the problem was really originally stated, but suppose we didn't know that and we only knew that the probability of Alabama winning was 1/6. Could I write that in terms of odds? And the answer is yes, and the result above shows you how to do it. Because you can see that this 1 is like the B. So you end up with saying, well, it's 1 over, and if there's a B up top, then there's a B down bottom. And so that tells you immediately the two numbers here have to add up to 6, so that must be a 5. And remember, the for number is always up top, so that means the 1 is the for number, that means the 5 is the against number. So if you understand this, it's very, very simple to go backwards and forwards. So once you break it up and you know that there's a 1 there, that means there's a 1 there and a 1 there, and then if the two numbers have to add up to 6, that means that has to be a 5. So changing it now back to an odds means just, now that I know what A and B are, I can do it. Again, the B was the 1, so that means the A must have been the 5. So the odds against Alabama winning are 5-1. So if I ask you to go from probability to odds, you should be able to do it. If I ask you to go from odds to probability, you should be able to do it. Another way of looking at it, I'm giving you lots of things, and some of these things it's just your choice of how to look at it, but I want you to have the tools so that you can take the way of thinking about it that makes the most sense to you. But another way of looking at it is this. If the probability of an event E is given as P of E, then the odds against that event can be written as the probability the event doesn't occur divided by the probability of the event occurring. And the way to understand that is when this is written as a fraction, I've been writing odds with a colon, but even though I've been writing my odds with a colon, it's equally correct to write the odds as a fraction, and that's the way it's written here. So sometimes you do see it written as a fraction. With the gambling, you usually see it written with a colon, but writing it as a fraction is equally valid. So if you did want to change this fraction back to a standard way of writing odds, the numerator would be on the left side of the colon, and the denominator would be on the right side of the colon. But it's equally valid to write it as a fraction. So for example, if I told you that the probability of E was 0.3, that means that the probability that of E complement, that's the probability that E did not occur, would just be 1 minus the probability that it did occur, so it'd be 0.7. So if the probability of E is 0.3, the probability of E complement is 0.7. So if I wanted to use this result up here to change it back to odds, if I wanted the odds against E, it would be the probability that E didn't occur divided by the probability that E did occur. The probability that E didn't occur over the probability that E did occur. So that would be 0.7 over 0.3. And if you simplify that, if you multiply top and bottom by 10, you get 7/3. Or you could write that 7:3. And you notice I did not use the 0.7 and the 0.3. Usually the odds are written as integers, so I just multiply the top and the bottom by 10 to make 0.7 into 7 and 0.3 into 3. Now you will seldom if ever have to convert to odds using this formula. I showed you how to do it another way, but I'm trying to give you all these tools and all these different ways of looking at things. So you'll seldom if ever actually have to use this result here to convert odds or to convert to odds. But it's there if you'd like to do it that way or if you'd like to think about it that way.